Hello dear students, in this video I will continue with the 5th unit probability. Here I will discuss about law of total probability or theorem of total probability and solve the questions from exercise 12.7 of chapter 12 CBSE class 11 applied mathematics by M.L. Aggarwal. Now before seeing the theorem on total probability, we will see what is partition in a sample space. We call a collection of events A1, A2 up to etc. AN as a partition in a sample space S if first condition A1 union A2 union up to etc. union AN. This is equal to the sample space S itself. And the second condition is AI intersection AJ equal to phi for all I comma j, I not equal to j. And the third condition is ai not equal to phi for all I. So we call these events A1, A2 up to etc. AN as a partition of sample space F. Yes, if these conditions are satisfied. So a partition is a collection of non-empty, non-overlapping subsets of a sample space whose union is the sample space itself. So if we consider the sample space S, we have A1, A2, A3, A4, A5, A6, all these are said to be partition in this sample space S, and these we can see that they are non-empty and non-overlapping subsets of this sample space S. Now we will see the law of total probability or the theorem of total probability. Say suppose we have an event P within the sample space S, then we can express this event B as B is equal to B intersection A1 union B intersection A2 union up to etc. union B intersection AN. So we can express B as the intersection of B and A1, B and A2, B and A3, B and A4 up to etc. B intersection AN. So as a result, using the addition law of probability for mutual exclusive events, here we can see that B intersection A1, B intersection A2 up to etc. B intersection AN, all these events are mutually exclusive. So using the addition law of probability, we can write probability of B as probability of B is equal to probability of B intersection A1 plus probability of B intersection A2 plus up to etc. plus probability of B intersection AN. And now using conditional probability, we have probability of A intersection any event AI. It is equal to probability of B given AI into probability of AI. This is using the definition for conditional probability. Therefore, we have probability of B, it is equal to probability of B given A1 into probability of A1 plus probability of B given A2 into probability of A2 plus up to etc. plus probability of B given AN into probability of AN. Now this is called the theorem of total probability or law of total probability. So probability of an event B can be expressed as probability of B given A1 into probability of A1 plus probability of B given A2 into probability of A2 plus up to etc. probability of B given AN into probability of AN. Now using this theorem of total probability, we will see the questions from the exercise 12.7. The first question from exercise 12.7. A purse contains 4 silver and 5 copper coins. A second purse contains 3 silver and 7 copper coins. If a coin is taken out at random from one of the purses, what is the probability that it is a copper coin? So here it is given there is one purse which contains 4 silver and 5 copper coins, and second purse contains 3 silver and 7 copper coins. Here a coin is taken out at random from one of the purses. We need to find the probability that it is a copper coin. So let E1 and E2 be the events. First and second purse are chosen respectively. And let A be the event which is getting a copper coin. So probability of E1 is probability of choosing the first purse, it is half, and probability of choosing the second purse is equal to half. So here it is given the first purse contains 4 silver and 5 copper coins, and the second purse contains 3 silver and 7 copper coins. So we have taken let A be the event which is getting a copper coin. We need to find probability of A. We just now saw from law of total probability, probability of A can be calculated as probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So we have probability of E1 and probability of E2, and we can find probability of A given E1 and probability of A given E2. Now probability of A given E1. Probability of A given E1 is nothing but it is getting a copper coin from the first purse. So probability of A given E1, it will be 5 by 9. And probability of A given E2, it is equal to, it is nothing but it is the probability of getting a copper coin from the second purse. So it is 7 by 10. So let us take this as 1. 1 implies probability of A is equal to half into 5 by 9 plus half into 7 by 10. So this is half into LCM is 90. So 50 plus 63. So it is 1 by 180 into 113. So it is 113 upon 180. So probability that it is a copper coin is 113 upon 180. Next question, a person has undertaken a construction job. The probabilities are 0.65 that there will be strike, 0.8 that the construction job will be completed on time if there is no strike, and 0.32 that the construction job will be completed on time if there is a strike. Determine the probability that the construction job will be completed on time. So here all the probabilities are given directly. So let us take, let E1 be the event there is strike and E2 be the event there is no strike. And let us take, let A be the event the job will be completed. So probability of E1 is the event there is strike. So it is 0.65. And probability of E2 there is no strike will be 1 minus probability of E1. So it is 1 minus 0.65, which is 0.35. Here we have to find probability of A using the theorem of total probability. So we need probability of A given E1 and probability of A given E2. So E1 is the event there is strike. Here it is given the probability that the construction job will be completed if there is strike is 0.32. So probability of A given E1 is 0.32 and construction job will be completed on time if there is no strike is 0.8. So probability of A given E2 is 0.8. So we have everything here using law of total probability. Probability of A is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So probability of E1 is 0.65. We have it here, and probability of A given E1 is 0.32 into 0.32 plus probability of E2 is 0.35 and probability of A given E2 is 0.8. 0.35 into 0.8. So this, when we multiply, we get 0.208 plus 0.28, or this is equal to 0.488. So probability that the construction job will be completed on time is 0.488. Next question. There are two bags. One bag contains 6 green and 3 red balls. The second bag contains 5 green and 4 red balls. One ball is transferred from the first bag to the second bag. Then one ball is drawn from the second bag. Find the probability that it is a red ball. So there are two bags. First bag has got 6 green and 3 red balls. The second bag has got 5 green and 4 red balls. One ball is transferred from the first bag to the second bag, and then one ball is drawn from the second bag. We need to find the probability that it is a red ball. So let us take, let E1 be the event, red ball is transferred, and let E2 be the event, green ball is transferred. And let us take the required probability that we need to find as A. Let A be the event getting a red ball. So here we have taken E1 as the event, red ball is transferred. It means E1 is getting a red ball from the first bag. So probability of E1 will be 3 by 9, which is 1 by 3. Then probability of E2 will be getting a green ball. So it is 6 by 9, which is 2 by 3. Now we need to find probability of A. To find probability of A using the law of total probability, we need probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So probability of A given E1. If E1 occurs, then the second bag will have 5 green and 5 red balls. So probability of A given E1, it will be 5 by 10. 5 red balls upon total balls. So it is 5 by 10. That is probability of selecting a red ball given a red ball is transferred from the first bag to the second bag. It will be 5 by 10. And probability of A given E2, it will be, if E2 occurs, then a green ball will be transferred. In that case, bag 2 will have 6 green ball and 4 red ball. So probability of A given E2, it will be 4 by 10. Therefore, probability of A is equal to, using the law of total probability, probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So this is equal to 1 by 3 into 5 by 10 plus 2 by 3 into 4 by 10. So here the LCM is 30. So it is 13 by 30. So probability of getting a red ball is 13 by 30. Next question. In a factory, a product is manufactured by any of three machines A, B and C. They produce respectively 25%, 35% and 40% of the total products. A product is selected at random. Find the probability that it is defective. Assume that machines A, B and C produce respectively 5%, 4% and 2% defective items. So here all the probabilities are given. It is given directly. So let us take, let E1, E2 and E3 be the events selecting machine A, B and C. Selecting a product from machine A, B and C respectively. So here machine A produces 25% means probability of E1 selecting a product of machine. So probability of E1 will be 0.25. Then probability of E2 will be 0.35 and probability of E3 will be 0.4. So when we select an item, the probability that it is produced by machine A will be 0.25. It is produced by machine B will be 0.35. It is produced by machine C will be 0.4. And let us take, let E be the event getting a defective product. So probability of E given E1, that is probability of getting a defective product given it is produced by machine A, it is 5%, which is 0.05. Then probability of E given E2, that is probability of getting a defective product given it is produced by machine B, it is 4%. So it is 0.04. And probability of E given E3, it is 2%, which is 0.02. So we need to find probability of E. So it is equal to probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2 plus probability of E3 into probability of E given E3. So it is 0.25 into 0.05 plus 0.35 into 0.04 plus 0.4 into 0.02. So if we simplify this, we will get the answer. So this is equal to 0.0125 plus 0.014 plus 0.008. So when we add all these, we get 0.0345. Or if we want to write it in fractions, it is 345 by 10,000. So this is equal to 69 by 2000. Therefore, probability of E equal to 69 upon 2000. So this is the probability that it is defective. I hope this video was useful for you. Thank you for watching.